Hi everyone and welcome to this video. We are going to present you Santec's web test system for polarization dependent loss measurement or STS-PDL. Santec STS-PDL is the right system you need for all your PDL characterization as it combines accuracy, speed, and high performance. Indeed, with the recent development of network technologies, industrials for both active and passive optical devices are designing new components that are reaching limits never seen before. This race leads to more sensitive devices that need to be manufactured in large volumes, short lead time, with no compromise on quality nor accuracy. This video will first explain what is STS-PDL consists of, then we will present you Santec's dedicated PDL software that will help you to measure, calculate, and analyze your data. In future videos, we will go through some examples to show you our system performances. Let's have a look on SWEP test system for PDL measurement. It consists of Santec's light source in O, CL or SCM band. Here we are going to use TSL 550 SCL band model, Santec's polarization control unit or PCU100 in corresponding optical band, either O band or C band. Here we are using the C band model. And finally, Santec's optical power meter MPM210. These instruments communicate between themselves and with your PC through GPIB, BNC, and USB cables. Let's see the connections from the rear side. The PC will be connected to TSL, PCU, and MPM through GPIB cables. We highly recommend using National Instruments hardware. Then, from TSL trigger output, connect a BNC cable to PCU's trigger input. From PCU's trigger output, connect a second BNC cable to MPM trigger input. Finally, using USB cable, connect the PC to PCU's USB port. The USB cable will allow communication between PC and PCU's integrated data acquisition board or DAC board. Now that all electrical connections are set, let's go back to the front panel and check what kind of patch cords you will need. First, connect TSL to PCU via polarization maintaining fiber. Then, connect PCU output and MPM channel with a single mode fiber. Now that all the hardware is set, we are going to use the STS-PDL software to control our instruments and measure our devices. Just go on PC desktop and double-click on the link. At software start, we have to configure all the tools accordingly. First, TSL GPIB address, then PCU GPIB address, DAC board address, and finally MPM GPIB address. Then click on Set and all STS-PDL is ready. Let's take a quick look at STS-PDL software. It is composed of sweep parameters panel, a control panel, and two graph areas. In the first panel, we will input all wavelength scan parameters, namely start and stop wavelengths, wavelength step, scan speed, and output power. The control panel will allow us to select MPM channels we are going to measure, take reference data, and measure actual device. Once the measurement is over, the system will display insertion loss and calculating PDL on dedicated graph areas. PDL is calculated using Euler matrix method. Now that all we need is ready, measurement process consists of first, taking reference spectrum to cancel out extrinsic noise and losses. Then, connecting and measuring device under test. Finally, analyze data. To see in more details software functionalities and demonstrate Santec PDL system capabilities, we will go through some study cases.